Hey students, this is Lesson 8.2, Quadratic Relationships. This is Lesson 8.2.1. We're going to learn how to link quadratic equations to their graphs, making parabolas. We're going to learn that to graph quadratic equations of the form y equals ax squared and identify lines of symmetry and vertices, and how to identify quadratic relationships from graphs, tables, and equations. All right, I'm going to skip ahead here and do a problem from your first set of homework here, and I think we can learn a lot from this problem. Right here, find that in your notebook. So we have three different equations. We have y equals x squared, y equals x squared plus 2, and y equals x squared minus 2. We know there's quadratic equations because they all have a squared term. It's as simple as that. If the equation has a squared term in it, then it's a quadratic equation. And we're gonna make some values here and graph these, and then look at some shortcuts we can use and some characteristics of quadratic graphs. So in the first equation, y equals x squared, all we have to do is multiply this number by itself. Negative 4 times negative 4 is 16. Negative 3 times negative 3 is 9. Negative 2 times negative 2 is 4. Negative 1 times negative 1 is 1. 0 times 0 is 0. 1, 4, 3 times 3 is 9, 4 times 4 is 16. Now notice how the values go down and then come back up at exactly the same rate that they were going down. That's the nature of a quadratic equation. So one way you can tell it's quadratic is by looking at the numbers. If they go down and then come back up, there's a good chance it's quadratic. Now the second one here, well, let's go ahead and graph that, and you should notice something else as we're graphing it. So let's change our scale here. Let's make this negative 1, negative 2, negative 3, negative 4. So we're changing our scale on the x-axis to 1/2. All right, and then on the y-axis, we need to get all the way to 16 to graph 4. So we're going to make that scale 2. So this will be 4, 8, 12, 16. Notice I don't have any negatives in that, and I know I'm not going to because this value will keep getting higher, and so will this value. So my range of values is always going to be positive. 0 is going to be the smallest number. So let's graph negative 4, 16. That's right here. Negative 3, 9 is right here. Negative 2, 4 is right here. Negative 1, 1. 0, 0. 1, 1. Notice how I have the same output values. So I can really just use the idea of symmetry here to graph these other points. I'm going to have a point in exactly the same spot above 2 as I have above negative 2. Same with 3 and negative 3. So I can just look at my other point and put a point in exactly the same spot. So we get points here, and at 4 we'll have them at the same spot, 16. Now that idea of symmetry, we'll just draw a nice curve in here by hand. This is a symmetrical object, and the line of symmetry is right here, right in the middle. That's called the line of symmetry. And in this case, that line of symmetry is the y-axis. And the equation for that is x equals 0. So right at x equals 0, we have a line of symmetry. And the vertex always lands on the line of symmetry. Vertex, and it's either at the minimum or the maximum. In this case, it's 0.00. All right, now we are going to graph a couple more here. And this one, notice I'm just adding 2 to the previous equation. That's just going to make each of my outputs 2 higher. So if I have 16 here plus 2, that would be 18. 9 plus 2 is 11, 4 plus 2 is 6, 1 plus 2 is 3, 0 plus 2 is 2, and now I'm going to have that symmetry thing going on again, so I can just write down the same numbers I have above there. Okay, now when I make the graph of those, I know my y value is just 2 higher, so we're at negative 416 on this point, right here. I'm just going to be 2 higher than that for the next one at 18. And likewise, I'll be 2 higher here, 2 higher here, 2 higher here at negative 1, 1. That would put me there. My vertex is going to be 2 higher. All my points are going to be 2 higher. And that's going to help me make this graph of y equals x squared plus 2. Okay? Now, thinking about that, the next equation, we are going to do y equals x squared minus 2. That's just going to be 2 lower than my original equation, which is going to give me 14, 7, 2, negative 1, negative 2, and then we duplicate those numbers. And we can use the idea of symmetry to graph those also, but they're just going to be all 2 lower, so thinking about that, I'm just going to make my dots all 2 lower. And then you can also use the idea of symmetry for your points. And so I get this curve now, for that one. Okay, so the important concept there is where there's a line of symmetry, that's going to help you graph them. Because you don't have to plot all the points one at a time. You can figure out where that line of symmetry is and then use that to put points in the same location just on the other side of the line of symmetry. Alright, so let's look at these equations quick here. I'm not going to do all these. I'll let you do some of them in class, but this equation to start with is y equals negative x squared. Well, remember we started last time with y equals x squared. That's these numbers. Negative x squared is just going to be the opposite of those numbers. So I can use that idea to graph these. Negative 9, negative 4, negative 1. The opposite of 0 is 0, and then the idea of symmetry again. Negative 9 and negative 16. And then I'm going to use the same scale. So this is negative 1, negative 2, negative 4, negative 3, negative 4, 1, 2, and I'm going to make this scale 2. So this is negative 4, negative 8, negative 12, negative 16. And then if I graph those points, I get negative 4, negative 16, which is right here. Negative 4, negative 9, right about. Negative 3, negative 9 is right about there. Negative 2, negative 4 is right about there. Negative 1, negative 1. 0, 0. And then the symmetry idea, putting them in the same spot on the other side of the y-axis. And then draw a curve in there. And so now you can see what the opposite of y equals x squared looks like. It's just a mirror image of the x squared, just upside down. Okay. Last thing I want to do here is just answer some of these questions. What similarities do you see in the same graphs? They really all have the same curve and the same line of symmetry. And the differences are the vertex has just changed. That's the only difference. So the vertex has moved up and down on the line of symmetry. Similarly, all points are either 2 higher than our original one or 2 lower. So, and the vertex is really the y-intercept. So the y-intercept has moved. You could say that also. All right, that's the end of this lesson. I'll see you tomorrow.